Hello, friends. Welcome to the Science Show, and today is March 2nd. So, let us find out what is happening in the area of science and what are the new discoveries. So, today in our show, we are going to discuss these three latest findings by the scientist. Number one is the nature of life in the red dwarf system. This is going to be very interesting, so stick around, friends. Number two is determining how cold is our universe. What is the mean temperature of our universe? And number three is again very interesting. How can we see in the longest wavelength? Can we actually see in the can we meaningfully create an image in the longest wavelength of light, using the longest wavelength of light? All right, so let us continue with our first point, which is life around the red dwarf system. So, friends, I think many of you who are the science buff know that nearly 70 to 80% of the stars in our galaxies are these red dwarfs. Red dwarfs are many times smaller, at least 10 times smaller than the sun. The sun is a relatively large star. Red dwarfs are small stars. And why we call them red dwarf? Because they glow red. They are very small. They also produce little visible light, and most of the light is reddish in tint. And as you know that the red light is less energetic compared to white light, yellow light, and blue light. We know that from our school days. If you remember your rainbow waveguide, you know that the most energetic light is the violet and the least energetic light is red. This is in the visible spectrum, and anything after the red light is called infrared, and anything above violet is called ultraviolet. We know that. So the entire electromagnetic spectrum consists of very high energy to very low energy, and therefore the red dwarf systems actually produce low energy, and because they produce low energy, they burn very slowly. The life of our sun is approximately 10 billion years, whereas if you compare that with red dwarf may live for 100 billion years, many times longer than the larger stars. So since these stars are small, they have a long life, they produce little heat, and therefore and they are smaller, so they will have less gravity. Therefore their solar systems are also very small, not as large as our own solar system. They are small. The planets are close by. So if there is a civilization, or there is some life which evolved in this kind of a system, then it will be a lot easier from hopping from one planet to other, because in our own solar system the planets are quite far off. On the other hand, if you look at the red dwarf system, the planets are close by. However, there is one drawback in red dwarf, because once in a while these red dwarf stars flare up, and they produce so much solar wind and solar radiation, at least 10 times more than what sun would produce in a typical flare up from sun. So these red dwarfs are known to basically fry everything in their system, and we do not know why they do that. But once in a while, these red dwarf systems actually produce huge flare. So far, assumption has been that red dwarf are ideal for life, civilization to develop, because they have longer time in space. However, since they flare up, they output so much radiation that scientists believe that there is no provision that any life can exist in such high radiation, because even if there is some life, it will just die in a flare up incident. However, now scientists started to basically contradict what they have been believing, which is just to prove whether the plants can grow irrespective of the flare up, but whether the plants can grow in a red dwarf system or not. Is the life low energy light sufficient to kickstart the photosynthesis process in plants, because that is the starting point of any life form. Even for us, if there are no plants, we will also perish. So the first life form which evolved on earth is basically the bacteria, which could do processing of sunlight directly. So the turning point on earth was the photosynthesis using chlorophyll. Certain bacteria were able to get the sunlight directly and use the sunlight to break down different elements into useful compounds, and that is how the life is driven on earth. Even today, plant produce food for other animals so that the other animals can live. If plant dies, other animals on earth will also die. Plant produce food because of the sunlight, and the process is called photosynthesis. So if red dwarf stars are such unique places, is it possible to grow plants in their low light? That is the experiment. And the good news is that the scientists were able to create red dwarf kind environment in a lab, and they were surprised that the cyanobacteria survived. Not only survived, they thrived, they grew in their population. And there is absolutely no difference if there is life on any planet in the red dwarf system. The speed of growth of these bacteria will be similar to the growth of these bacteria on earth. So this is a very good, very positive sign that in case one of the planets which is much larger, has sufficient gravity and atmosphere, water, etc., all the conditions which are suitable for life in a red dwarf system, then the chances are that the life can evolve. And probably the atmosphere has magnetism, strong magnetism and thick atmosphere, that will also protect this life from these radiation which is coming out from the red dwarf. So I think all in all, this is a very good indication that most of the stars in the galaxy, 80 to 70 to 80% stars are red dwarf, and many of these red dwarf systems have larger planet, ocean worlds, even terrestrial planets like Earth with thick atmosphere, water and magnetism. So I think this kind of study proves that I think there is huge potential for alien life to not only be found on these planets but also thrive and probably become more complex life form just like we have on Earth. So it's a good news, all in all. Let's move to the second item that we had on our list, which is the temperature of the space itself. We know that the temperature that the humans require is something like room temperature, as we call it. Something like 25 to 35 degrees is the best temperature for us to live. Even though people live in very low temperature on Earth and also very high temperature, but all in all, the average temperature that we expect for us to live, comfortable temperature, is about 20 to 35 degrees if we just average it out. But it's not only for humans. Most of the life, almost 80% of the life, like this temperature. But if you go out of the Earth system, then if you go out in open space, the temperature drops rapidly. However, does it become zero or zero, not 0 Celsius, but 0 Kelvin? It is not zero. So there has to be some temperature, ambient temperature in the space itself. And that is where the challenge is. And in fact, the scientists have been trying to find what is the mean temperature of the universe. Because when the Big Bang happened, obviously temperatures were probably infinite. Scientists say that it became, there are so much high temperature located at one point that its entire system became sort of imbalance and actually exploded into a Big Bang. And since that point, temperature is only reducing. It's becoming cooler and cooler. But if it becomes zero, then the temperature will prevent any new activity happening in space. So the temperature cannot be zero, and the difference in temperature, the fight between heat and cold has to continue for a successful propagation of the universe itself. So what is the temperature? So when it was millions and billions of degrees at the time of Big Bang, and then Big Bang happened, taking that temperature out in the open space. So there are places in our universe which are very hot, like sun, stars, different stars. Some are hot, some are cold, and the temperature is very very high. It runs into trillions of degrees sometimes, and whereas in the open space the temperature is not so high, and on planet like Earth, temperature is very moderate. That is what the humans and living things expect temperature to be. But if you go to Venus, temperature is still high. So what is an average temperature? Now there are different techniques scientists have used, because we have to know exactly how rapidly the universe is losing the heat, so that we can determine how long we have to live. So I think the scientists have actually carried out this study, and they have actually calculated accurately what is the average temperature of the universe, and this is something like 3 Kelvin. 3 Kelvin, which is equal to, if you follow Celsius thermometer, it is equal to minus 271 degrees. That is the average temperature of our universe today. So from our standpoint, it's quite cold, but it is not absolutely cold. It is having some heat still left in it, and that heat is 3 degrees. And absolute temperature cannot be achieved. I hope you know that absolute temperature is minus 274. So it is 3 degrees higher than the absolute temperature, and just like absolute heat, absolute zero cannot be achieved, and to reduce temperature to absolute zero is impossible. So right now, that mean average temperature of universe is 3 degrees Kelvin, which is minus 271 degrees Celsius. All right, let's move to the last item on our list today in the science show, which is how can we basically image various objects in the longest wavelength. And as I told you about light consists of electromagnetic waves from very high energy to very low energy. So highest energy that we know is gamma ray, which is also part of light only, but it is gamma rays can destroy life instantly, because these photons, gamma ray photons, are so energetic they will burn everything. And after that, X-rays, and these particles are so energetic they can pass through our bodies, and that is why these because of these properties we use X-rays to take our X-ray photographs to find out what is going on inside our body. And therefore, so as the energy of these electromagnetic wave keeps reducing, it reaches a point where we start seeing this, our eyes start seeing this, which is what we call the visible light, which consists of 7 colors. But then that the energy further reduces after infrared, and the lowest energetic light waves that we know of are the radio waves. And typically, lower the energy, longer the wavelength. That is the equation. Higher the energy, shorter the wavelength. If you look at the gamma ray, the wavelengths are in nanometers. They are so energetic, vibrating so much, and the wavelengths are also very very short. Whereas in the case of radio waves, the wavelength can be almost a kilometer, because these the photons of light in the radio wave spectrum has become so less energetic that their wavelength is almost equal to sometimes 1 kilometer. So if we have the capability to convert that into vision, the challenge is, how are we going to see the things? How do we see the universe? How do we see different planets in the longest wavelength? And this idea has basically come up after the Starlink project of Elon Musk, where Elon Musk Starlink project started sending low cost satellites, low cost, low intensity satellites, smaller satellites, but many in numbers to cover the entire earth in order to provide internet services across the surface of the earth. So these kind of satellites are also very suitable to basically make a planet-wide array to capture the long wavelength. So this idea has come that can we use some of these satellite or similar satellite network, just like Starlink satellite network, to convert using some sort of software into a long wavelength image of our space, of the things that we see. So when we use very high powered telescopes like JWST, which is also seeing in the red spectrum, but then even smaller, longer wavelength and less energetic photons, can we see and create an image out of it? So I think this is a very good idea, because we will learn things. Probably we will start seeing things which no other telescope has been able to see before. I think this is a holy grail of next development, because there could be objects lying in our open space with very little heat in them, and they may be sending information in the radio wave, a very low intensity radio wave, which we tend to ignore because it's very difficult to capture them. But if we have a planet-wide array of these smaller satellite spread across, then using the combination of various satellites, we will be able to capture these long wavelength and convert that into an image. So if we have that kind of technology, we maybe start to see things which are usually not visible in any kind of visible light or infrared or any kind of way. So if we are able to create this system and if follow through what scientists are saying, then we may have a totally different view of our space-time. So it's very exciting from my point of view. But I like to know from you, what do you think about this? I look forward to receiving your comments, and I will catch you again tomorrow, same time in the Akulmach Science Show. Until then, please take care. See you tomorrow.